handling in chemistry, basically acids, bases, and salts. So previously we discussed if acids, bases, and alkalis, and then we started on salts. So we discussed the types of salts, preparation of various types of salts, and then we had finished preparation of salts using the major preparation of soluble salts. And among those methods, one we are looking at the titration, and the other one where we have to react an acid with a metal, an acid with a metal oxide, an acid with a metal carbonate, and an acid with a metal hydroxide, just obtain a solution, and we carry out what we call crystallization. So with salts prepared by titration method, those are salts whose oxides, carbonates, and the hydroxides, even metal, are all soluble in water. So we can easily obtain the solution when we react a metal hydroxide with an acid. Then that can be done by titration, because all the solutions are what? Soluble in water. For instance, the other time we looked at preparation of sodium sulfate, and we said sodium sulfate we need reactants, sodium hydroxide solution plus sulfuric acid solution. This reaction gives us sodium sulfate plus water liquid. So to carry out this preparation, we do what we call titration reaction. And titration means we get a burette, as I said the other time, and a pipette. So if this is an alkali and this is an acid, so we pipette a known volume, a volume of sodium hydroxide into a beaker. Maybe you can say we have pipetted 25 cubic centimeters of sodium hydroxide. Then come add an indicator, add phenolphthalein indicator. Phenolphthalein indicator. Because we say that when this indicator is added into alkalis, the indicator changes to what? To pink. Then we put dilute sulfuric acid into a burette. Then we carry out the titration. After the titration, we find out the titration. Then why do you carry out the titration? To find the end point of the reaction. What is the end point where you see any change in the color of the indicator? Once the indicator changes, maybe from pink to colorless, means that the reaction has ended. We go on the burette and we see what volume of the acid has been used to neutralize the base on the alkali. So you carry out the same procedures by pipetting again 25 cubic centimeters of the alkali we put into a flask. After there, you go and read, you measure exact volume of the acid used at the end point. If maybe 22 cubic centimeters were used to neutralize 25, you come back and measure exactly 22 cubic centimeters add it to 25 cubic centimeters. From there, the reaction takes place. You start a mixture, then you get your sodium sulfate, which is in solution, but we want it in crystalline form. Then you carry out what you call the crystallization mechanics. For example, we shall say we want to prepare sodium sulfate. If you want to prepare sodium sulfate, how are we going to do? Shall we say we pipette a known volume of sodium hydroxide. Sodium hydroxide into a clean conical flask, to a known volume of standard. This sodium hydroxide must be standard. Create a known volume of standard sodium hydroxide solution into a clean conical flask. Then we titrate the solution. Titrate the solution with dilute with standard sulfuric acid from the burette. Using phenolphthalein indicator. So this indicator will help you to know which volume of the acid is required to neutralize the base. The volume of the acid required in the reaction. So from there, we note the volume, note and record the volume of the acid at the end point. Of the acid at the end point. Note and record the volume of the acid at the end point. So from there, you repeat the titration. You can say repeat the procedures by using, we can set a fresh volume of sodium hydroxide. A fresh volume, the one you measured again, because you measure the same quantity of the sodium hydroxide measured first, same volume. That is V1 cubic centimeters of sodium hydroxide. Add exact the volume of the acid V2 cubic centimeters at the end point. Without an indicator. Then from there, start the mixture. Start the mixture, full stop. Then we carry out the crystallization process. From there, what do we do? Evaporate evaporate the solution. Evaporate the solution to saturation point. Saturation point. From there, allow the solution to, because the other side, this time I said saturation point can mean until crystallization point, or you can evaporate to near dryness. That's the time until you boil that mixture until crystals start to come out, or when the solution is much saturated with the salt you want to prepare. This saturation point, allow the mixture to cool so that crystals can form. Stop. Filter of the crystals. And wash them using cold distilled water, and dry them between filter papers. Dry the crystals between filter papers. Then we have the equation of reaction, which is sodium hydroxide plus sulfuric acid. Then we shall get sodium sulfate, then plus water liquid. Since we want crystals, we need to involve the equation for crystallization, and that is sodium sulfate, but in solution form. Since when we say to saturation point, allow solution to cool, this is where crystallization takes place. Meaning that this salt when it's being formed, combines with a certain amount of water, which is what we call the water of crystallization. And every kind of a salt or any salt has its amount of water it holds in its crystals. So as the solution cools, the salt or that compound combines with that water such that the water keeps it in crystalline form. Since we need crystals, so this sodium sulfate will combine with 10 molecules of water of crystallization to give you sodium sulfate 10 water crystals. Then this is what we call a solid. So this is how we can prepare salts by titration method. Other salts you can get by this method, we have other salts. We can have sodium nitrate or sodium salts or sodium salts, except sodium carbonate. Sodium carbonate or ammonium salts. Or potassium salts. Except potassium carbonate. And hydrogen carbonate. given here except sodium carbonate and sodium hydrogen carbonate. So other salts of sodium, potassium, and ammonium are all prepared using this process. Now this is a normal salt. But if it comes to unacid salt, remember we said that unacid salt is formed when part of the hydrogen ions of the acid have been replaced by a metallic ion or an ammonium radical. So if you are preparing unacid salt, you must make sure that unacid salt has what we call hydrogen ions or hydrogen atoms in its molecules. So that one is obtained when we have much of the acid and the base. For instance, if you titrated, if you have pipetted 25 cubic centimeters and you want to prepare it by neutralization, and in the first place after titration, this is sodium hydroxide. So on titrating, you use 23 cubic centimeters of sulfuric acid. So if you want an acid salt, the fresh volume of this sodium hydroxide, the V1 remains. But when we come to V2, volume of the acid we add, we need to double the volume of the acid. If here we say add exact, but if it was an acid salt, then we say add it twice as much as the volume of the acid used at the end point. If you have used 23, so when it comes to sodium hydrogen sulfate, we shall use 24, or I mean 46, twice as much as you have used twice as much volume of the acid you have used at the end at the end point. That's how we can get sodium hydrogen sulfate. Let us see it here. Let's see it clear here. It is sodium hydrogen sulfate. Sodium hydrogen sulfate. I'm not going to lab off here. Just going to follow this thing exactly. If it is for sodium hydrogen sulfate, then here we say add twice as much. Add twice as much as the volume of the acid at the end point, as volume of the acid at the end point. The procedures remain the same. That will be the same for potassium hydrogen sulfate and sodium hydrogen sulfate. But potassium hydrogen carbonate and sodium hydrogen carbonate, those ones we shall see them in the earlier discussions when we come to carbonated compounds, most especially sodium carbonate and sodium hydrogen carbonate, which will be prepared by other methods which we will see in carbon and its compounds. So that's how you can prepare these soluble salts by neutralization or titration methods. In another aspect, look at precipitation method. Precipitation method. Precipitation method of preparation of salts. This method is applied when we are preparing insoluble salts, salts that do not dissolve completely in water. method. Method is used to prepare insoluble salts. Insoluble salts. And insoluble salts, these are salts which do not dissolve in water, and hence form suspensions, form suspensions. What are suspensions? That is a liquid substance containing solid particles which spread throughout it, and if you leave it to settle, don't stand, those particles settle down on standing. So when you get an insoluble salt and put it in water, it will not dissolve. You will see the whole liquid having particles suspending throughout it. If you leave it to stand, then those particles will have to settle down on standing. So preparing those salts, we use precipitation method, or this method can be said double decomposition, and also call it double decomposition. Double decomposition method. This method of salt preparation is applied when we are preparing salts, like examples of salts prepared by precipitation method. Examples of salts prepared by precipitation method. What do you think? We have this salt here, this chalk dust. This chalk dust, the compound in it is highly insoluble in water. So if I bring this chalk dust in water, particles won't dissolve. However much I shake, they won't dissolve. You see, the whole liquid will have those solid particles spreading throughout it. Shall see the whole liquid having particles that spread throughout it. But if I leave it to stand, then these particles will settle at the bottom on standing. So all salts which do that, those are said to be insoluble salts. But if the salt was soluble, then you can't see these solid particles spreading. The solution will be clearly seen. So an example is this chalk dust, which is probably calcium sulfate. So examples of salts prepared by this method, we have all carbonates, exception of sodium carbonate, potassium carbonate, ammonium carbonate. The rest of the carbonates are soluble in water, but these ones, the rest are insoluble. But sodium carbonate, potassium carbonate, and ammonium carbonate, those ones are highly soluble in water. So these ones cannot be prepared by precipitation method. Another category of salts, we have sulfates of barium. That's barium sulfate, lead-2 sulfate, and calcium sulfate, which is probably this chalk dust, which is calcium sulfate. Its particles have settled at the bottom on standing, but if you just shake it, those particles keep on spreading throughout the whole what? Liquid, which is what we call a suspension. Then we shall have chlorides of lead 2 chloride, silver chloride, silver chloride, mercury 2 chloride. Then halides of lead 2 halide. These are basically prepared by precipitation method. So when we are preparing such salts, we must have 2 aqueous solutions set to react. 2 aqueous solutions. One solution must contain the ions for the cation. The other solution containing the ions for the anion of that salt you want to prepare. For instance, you want to prepare barium sulfate. So you must have 2 solutions. One containing barium ions and another containing sulfate ions. Such that if these 2 come into reaction, they will simply give you barium sulfate when you are obtaining an insoluble salt. Okay? If you want to prepare lead 2 chloride, so you must have one solution having lead 2 ions and another one having chloride ions, such that if these 2 ions come into contact, they will simply give you lead 2 chloride. But since that lead 2 chloride is insoluble, it comes out as a solid product. Barium sulfate being insoluble comes out as a solid product. And that's why the method is said to be precipitation, because these salts are obtained as precipitates. Why precipitates? Because they are solid products obtained when 2 aqueous solutions are being set to react. So that product is what we call a precipitate. So all these salts are all prepared by precipitation method. The barium sulfate, lead 2 sulfate, calcium sulfate, lead 2 chloride, silver chloride, mercury 2 chloride, and lead 2 halide. So let us see one of them. Let us see preparation of lead 2 sulfate. Preparation of lead 2 sulfate. Preparation of lead 2 sulfate. Since we have said that it's prepared basically by precipitation, we are going to have 2 aqueous solutions that are set to react. One is solution of lead 2 ions and another solution of sulfate ions. So the soluble salt of lead we know is nitrate, because all nitrates are soluble in water. So when we are preparing lead salts that are insoluble, we use lead 2 nitrate solution. Then we get another soluble sulfate, can be sodium sulfate, potassium sulfate, ammonium sulfate, any soluble sulfate. When added onto solution of lead 2 ions, we come up with a white precipitate of lead 2 sulfate. For instance, we shall say to a solution of lead 2 nitrate, solution of lead 2 nitrate is added dilute sulfuric acid, dilute sulfuric acid. Cannot measure quantities, but as long as you simply get these solutions and mix. And remember that they must be standard. So long as you get unmixed when they're highly standard, with concentrations which are high, precipitates can easily come out. Lead to nitrate, add the sulfuric acid. A white precipitate is formed. White precipitate is formed. That is lead to sulfate. Then we continue to add the sulfuric acid. Why do we continue to add the sulfuric acid? To ensure that all the lead to ions have been completely precipitated out as lead to sulfate. Continue adding lead to dilute sulfuric acid, sulfuric acid to ensure complete precipitation. Why do we ensure complete precipitation? We completely add such that the lead to ions have completely precipitated out from the solution as lead to sulfate. Then from there we filter off the precipitate. Filter off the precipitate, or can say allow the mixture to settle. And decant of the liquid. Allow the mixture to settle and decant of the liquid. So from there, we dry the precipitate, dry the residue after filtering, dry the precipitate between filter papers. Or in an oven, hand and half lead to ions coming from the solution of lead to nitrate, sulfate ions coming from the solution of sulfuric acid, then you get lead to sulfate. And the anionic equation is only written for the product which is in solid state, liquid state, or gas state, or solid, gas, liquid at room temperature. Don't write any equations for the solutions. That are for solutions, we must follow the states of matter: solid, liquid, and then gas. Why do we call it a precipitate? Because it's obtained as a solid product after mixing two aqueous solutions. So that solid product is said to be a precipitate. So we shall come back in the next session. Stay well, stay safe.